Okay guys, so let's go ahead in the next segment of this definition. Let's actually handle the trig part. And the first thing I kind of want to lay the foundation for is this is something that you're new to looking at, right? So in the past, what we usually did with our functions, right? Our functions were usually some function of x, right? And then as a matter of fact, we called f of x y. So you're used to seeing things in terms of x and y. As a matter of fact, we're still kind of doing it over here. But what's different about our trig functions is the input's not the x coordinate and the output's not the y coordinate, right? Like they traditionally are back in college algebra. The input for our function is actually an angle theta. So you give me an angle theta, right? And again, there's an infinite number of right now. Just our example is this theta in quad 1, but it doesn't matter how big or how small this angle, or if I'm quad 1, quad 2, quad 3, quad 4, whatever the case might be, right? We're going to take the sine of that angle. We're going to take the cosine of that angle, the tangent of that angle. So the cosecant of that angle, secant of that angle, cotangent of that angle. So the input for our functions is no longer x. It's actually going to be theta, right? Until we kind of shift the ground on you again. But that's the first thing you have to be aware of. The other thing that's going to change, right, is the output is no longer just y, right? The output, when you give it an angle, what you're going to get is a ratio of x, y, or r. So there's, in this picture, there's three things. There's an x side or an x coordinate of my point. There's a y side of my right triangle, or there's a y coordinate of that point. And then there's the r, the distance from 0. And so as we saw earlier in when we were talking about right triangles and the ratios in them, right, there's actually 6 ratios that I can form. And each one of those ratios creates one of our trig functions. So the y to r ratio creates the sine function for the angle that's given. The x to r ratio gives the cosine of the angle that's given. The y to x ratio gives the tangent of that. And then of course we can take the reciprocals and we get the cosecant of r to y, the secant is r to x, and the cotangent of theta is x to y. And so those are basically all the 6 ratios we can form with the sides of a right triangle, right? And each one basically forms a particular trig function. And that's basically what our semester is all about. We're going to investigate the sine function. We're going to investigate the cosine function. We're going to investigate the tangent function and so forth and so forth and so on. So again, the first thing, trying to relate this and maybe break away, if you would, from our old tradition of letting x be input and y be output and the function being called f, right? Our input is now an angle, all right? And our output is some ratio, right? Some fraction of x, y, and r, right? And so, and then the last but not least, what we have is the name, right? We're used to, f of x and g of x or h of x, right? We're used to the function name just being a singular letter. But here what we're doing is we're actually using symbols, if you would, right? That sign actually represents a sine function, right? And so that's telling you that for the angle theta, we are considering the ratio y to r. That's different, right, than the name of the function called cosine, right? When I'm invoking the cosine of the angle, we're talking about the ratio x to r, right? And then the tangent of theta, we're talking about the ratio y to x. And I'll let you guys cosecant, secant, and cotangent respectively. And that's important because as you guys do work, and yes, I'm going to take points away for this, right? If you're showing your work and you're just writing sine, plus cosine, right, minus the tangent, I'm actually going to mark you wrong there. And the reason being is sine and cosine and tangent, the way you've written them there in that expression, are actually meaningless, right? It would be like just writing f and g and h, right? Because we're basically talking about a function name. And so you're going to have to get your full credit. If you mean sine, right, you were talking about the sine of an angle. Now this has meaning, right? Cosine, again, to give it meaning, we're talking about the cosine of theta. So we're talking about the output of the sine function when the input's theta. We're talking about the output of the cosine function when the input's theta. We're talking about the output of the tangent function when the input is theta. And so now we actually have meaning. And if you would like, I would challenge you guys, go to your calculator and actually try this out. I would, again, make sure your calculator's in degree mode And if you just type the sign and press enter, you're going to get an error, because this is meaningless. It has no meaning until you give it an input, right? You have to have an input. Again, a function is an input-output system. To get the function rolling, you need to put something in it. If you don't put anything in it, there's nothing the function can do. So that's why sine by itself is nothing, but if you gave it the sine of 30, you're actually going to get a value out, all right? Because now I've given the value meaning. If you took the cosine of 30, you'll get something out. If you took the tangent of 30, you would actually get something out. You get, again, some ratio, right, for the sine of 30, the cosine of 30, and tangent. So please be very careful. That's your first warning, right? So sine, cosine, and tangent are basically function names. And if you just use them all by their lonesome, you actually have no meaning at all. It's an error, right? To give it meaning, we have to give it an input. And in this case, the input is some angle theta, okay? And then unlike the distance formula over here where I was able to prove it to you and show it to you, there's really nothing to prove here, right? It's a definition, and our proof is that using two other ways to define it, this all makes sense. We actually can use this to do a second and a third definition, and then of course there's the applications themselves, right? Physics applications, engineering applications, you name it. All the applications we need to mathematically model our world, this definition marks it right on the spot, right? So we know these definitions work. We can graph these functions, as you'll see. We can talk about their domains and ranges. We can solve equations with them, all right? And so we know these definitions work, even though I didn't technically prove it to you. It's just kind of something I'm stating to you, right? So hopefully that kind of gives you an idea of what's happening and why it's happening and what it's going. Again, we're basically just borrowing from our old traditional college algebra view, and we're giving it a function name, and we're giving it an input, and then depending on the function name, it's telling me which ratio. So the ratio for sine of an angle is different than the ratio for cosine, tangent, cosecant, secant, and cotangent. All right, and of course now we have a whole course to develop. Obviously I've got to cut some more videos where we do more explanation of this and actually put it to use. All right, so I'll see you guys in some upcoming videos.